Okay. All right. Good morning, everyone. How are we doing? Good, good. All right, great. So my name is Calvin Zhou. I am from W3B Education, which is a nonprofit that I'm a part of that focus really on student innovation. And I hope this is kind of a prime example of that. And I'm a high school student from San Jose, California at Lindbergh High School. So I'm here to present AIBEE, which is an AI-driven block coding educational environment for teaching prototyping and really providing lessons on AI. So it's kind of there you go. All right, cool. So, sorry, this took a while. So we understand here that AI education is crucial for preparing everyone in kind of this AI era. And so a lot of these prerequisites is very high challenging math and kind of programming, whether that's linear algebra or very deep understanding of Python and a lot of these libraries, whether it's TensorFlow or PyTorch. And a lot of these lack of resources, especially for youth and in this field. So a lot of intervention on how to allow youth to really get into programming is with block coding. And so kind of a thought experiment is why block coding for education and how we can really build a platform to do that. So the idea is to really simplify learning through these kind of puzzle style pieces, as well as really lowering the barrier to entry for these visual and interactive tools, and also kind of reducing the intimidation of a very complex algorithm if you were to write it through code. And so with current approaches, you see that either you go take a course on Coursera, Udemy, or through university education. And so the idea of kind of a lot of this is how do we take a more high level, people who are more interested in the technical aspect and really get that into a more adaptable and usable so it can be deployed and into some real world applications. So kind of moving on to what this really looks like, it's a kind of AI-driven solution to block coding. And so it's an integrated block coding web environment with kind of drag and drop blocks that is very similar to Race's Playground or MIT App Inventor and Scratch. And instead, it's more focused on a little bit more niche on how you would see a machine learning code run on, let's say, a Jupyter notebook. So you see the code that's generated on the side, as well as a chatbot for instructions and new block generation. And I'll kind of go a little bit into more detail about the new block generation aspect that can be a very interesting to explore in the future. And so the idea is to learn by do, right? That's kind of the motto of MIT, as well as to how do you train and create these models, as well as deploy them to external use. And so the idea behind this is the implementation is kind of based on a web app hosted on React.js and Google Blockly. And so the blocks actually match individual Python code snippets on a Jupyter notebook, and that's also run on a concurrent server. And so the idea behind this is that you can see the execution results in real time, and through this you can actually see yourself. It's kind of as if you're coding, but not actually writing a lot of code. So the kind of deal with a lot of these no-code and low-code environments is to make it more accessible and for education and AI to be adaptable. And so the idea is that how do we take this and make it into something that anybody can really explore, whether that's a high school student or whether you're a corporate who are looking into getting people interested in how do we develop these applications without requiring an extensive course and an extensive background on code. And so this is something as a high school student that I feel really passionate about, because it's something that you see that I think Matthew said earlier, you want to teach high schoolers quantum computing, and that's something that may seem intimidating, but at the same time when you really break it down, it's something that you can really teach and really provide. And whether this is from different age groups, and more future testing on how we take control and test and treatment will really be developed in the next few months. And so kind of, I guess, to really breeze through this and go through future work, as well as a little bit more discussion on some topics that I found a little bit more interesting through this process, is that as a summary, this project creates really an environment for learning, teaching, and prototyping AI. And so the goal is to make it accessible to all, regardless of any prior knowledge. And so some future work that can really implemented is, to research curriculum and block generation with LLM models. And to kind of dig into this a little deeper is that currently a lot of the code that is in each block is kind of hard-coded, right? Whether that's, any type of feed or any type of data set needs to be hard-coded into it. And so whether you're trying to, let's say you run any type of model, and let's say you're trying to backpropagate it, you wouldn't, the current development on my end would be to actually write that out. And so the issue is, let's say the user is trying to explore something different that the current system doesn't have in place. So when the current system has nothing to generate for that block, do we stop there? And so the question is, can we use an LLM model that is domain specific and generated so that it's only for generation of new blocks? And so we have it in a control setting. So let's say the user types in the chatbot, can you create a block for me to explore XYZ model? And so this is something that is, a very complex thing to really implement. And over time, you see that this could really allow for further development of, let's say, in general, a modularized code and how that can be applied to different areas. And so another area group, as I said before, is to kind of take experimental teaching and compare it with different AI solutions, right? Whether that is courses or whether that is, on a lower level, as for, let's say, younger students for Scratch and MIT App Inventor. And so using that and really seeing, is having this high-level code where you have a lot of these complex features in this implemented, as you kind of go back, if you really look a little bit carefully, whether this is, like these feed-forward neural networks, it's very detailed, and you see that is it intimidating enough, and how are you really making sure that there's a balance between there. So I guess, and also another area we could really explore is, creating an AIBEE Box. And so this is a low-cost battery-powered mini computer with a Raspberry Pi and touchscreen for offline use. And so whether or not we can deploy this into a very modularized area, and that it can be, implemented to different groups. And this can be really seen in a lot of different solutions. So this is something that can be explored adjacent to a lot of the work that MIT Raise and Active are doing. So if you have any ideas on a lot of these things I'm talking about and any feedback, please feel free to talk with me after. And thank you so much for your time.